I'm prepared to watch Steve do all the work.
That's right.
Yes.
Thank you, Steve.
Thank
You're
you,
the best,
Steve.
man. Can't wait to watch this.
We're officially live. Don't say anything secret.
That just like killed the conversation completely. Like no one's saying anything.
Okay.
Saying
Go ahead and say secret stuff. That's fine.
Let's tell them about all of our secret open source projects we're working on.
Did I ruin your roadmap for today's thing? Was all telling secrets. This is exciting. So today we have the entire Blazor team.
Hi.
We have a large portion. Is this the entire Blazor team?
Yeah.
Well, that's not to be clear. I mean, that's not entirely fair because this is all the people that are working on like the Blazor UI framework. But like behind us actually sits a whole bunch of folks that actually work on the .NET runtime that works on WebAssembly, and those folks aren't here. So Rodrigo and Laurent and Ken and those guys, they're not part of Blazor per se, but Blazor wouldn't happen without them. So there's actually a bunch of other folks that work on Blazor that aren't here, but this is the folks on the ASP.NET team that work on the Blazor Web UI framework.
Awesome. Okay, so before we get too far into it, I know all of you have been on the show several times before, but why don't we go around and introduce, do introductions. So everyone say who you are and do you want to say what you work on?
Sure.
Okay.
So I'll start. I'm Ryan Nowak. I'm a developer on the ASP.NET team. I work on ASP.NET MVC, Blazor, HP Client Factory, routing, Blazor tooling, that kind of stuff.
Okay, so for me, I'm Javier. I also work on the MVC team. I work on a bunch of stuff, testing, HTTPS, UI and class libraries, and also on Blazor on the lower level, like build stuff, interrupt things, all those type of fun stuff.
And I am Dan Roth. I don't know, what do I do? I work on our web framework platforms. I work on ASP.NET Core. But most of my time, honestly, I spend working on Blazor, which is where all the fun's at.
Cool. My name's Steve Sampson, and I'm yet another developer on the ASP.NET team. And Blazor is my main focus at the moment. The other thing that I do sometimes is the single-page application stuff for ASP.NET Core, so the React and Angular templates and all of the supporting technology for that.
Awesome. Okay, so before we get too deep into all the demos and excitement and news and stuff from your team, let's run through the community stand-up links. And I have a lot of ASP.NET stuff in general, including some cool Blazor content at the end. I am sharing my screen, hopefully. Okay, so starting here with this one. This is a cool post. So David Fowler did kind of just a Twitter thread on here's some cool like hidden gems in ASP.NET Core 2.1, and there's a lot of stuff that's there's some big banner features that we talked about, and then like all kinds of stuff, HTTPS and Razor UI and class libraries and identity stuff and GDPR and et cetera, et cetera. But then there's a bunch of like cool stuff that if you dig a little deeper is in there. So David wrote this up in a Twitter thread, and then Scott Hanselman kind of filled it out in a blog post. So going through generic host, I-hosted service, Windows services on .NET Core, pretty cool. Configuring using iHosting Startup, shared source packages, etc. So you can go through and read all this, and kind of it's nice to be able to kind of dig in a little deeper and see some of those more advanced features.
Ah, wow. We ship this stuff? I'm going through it. There's a lot of cool stuff here.
A lot of stuff in there, yep. So speaking of shipping stuff, there's Damien tweeted about this. So this is the .NET Core 2.1.1 early access downloads. So this includes ASP.NET Core. So this is my understanding from reading this is a servicing release. So this is bug fixes. So this early access is if you want to test this pre-release. And there's caveats, and it's stuff you've got to do as far as setting up the NuGet packages, etc. At the bottom of this, it links over to what is actually fixed in this release. And so, for instance, here you can see the list in GitHub, all the GitHub issues for ASP.NET Core 2.1.1, what's been fixed in there. So good to know about. If you want to do early testing before it's released, this is a good way to both see what's in there and also test it out. All right, now we're to a little of the more advanced rocket surgery portions. So first of all, Andrew Locke digging into a few ways of suppressing the startup and shutdown messages in the console from ASP.NET Core. So the issue is if you're using structured logging, the startup and shutdown messages are not structured. So you have these structured log messages that work great with your structured logging systems, and then the kind of, hey, we're starting up, that doesn't work for him. So there's a few different ways to control that, and he kind of digs into those. A simple way is using environment variables. So there's actually this ASP.NET Core suppress status message. Then also looking at ways you can do it using use setting. And then also in ASP.NET Core 2.1, going in and configuring using iHosted service. So, and what I like with all this, there's a lot of information there, but then down at the end, the summary kind of wraps up everything you need to know there. So obviously, I think the simplest one is setting it using an environment variable potentially, but you've got options.
Does he say we should do anything to make that scenario better, or is it just like is he happy with that workaround? Like, should we actually make the structured logging scenario actually work better for that case? Maybe there's a improvement in that post. I don't know.
You know, the way he writes it, it's just like, well, this is frustrating. Here's how I can configure it. It does seem like because of that environment variable, that's relatively straightforward to me on reading this, that I can change that. But I honestly don't know. That'd be interesting for people on the chat to respond to. And then Andrew, if you think we should change this.
I do notice that in David, in one of the hidden gems that I'm looking on Hansman's blog post is there's a suppress status messages extension method off of the web host builder that sounds like at least that does something similar. I don't know. So maybe we actually did work for that thing already in 2.1. Might be worth checking out.
Yeah, and I am verifying something real quick. I need to make sure that I actually did the go live thing on here because. Okay. We may have some people going, what? It's not started. I'm not sure. We do have people on the chat, but they may have had to join through YouTube. Okay.
I'm showing live, like it says.
Yeah, live. It's on live. It wasn't on the live.asp.net site yet. So probably there are some people freaking out on the Twitters. But
it wasn't live a few minutes ago, Andre says.
Yeah, and this is okay because the exciting stuff is all still to come with the Blazor team.
This is just actually part of the normal script of our community stand-up. So
yeah, it's to build the suspense.
Is getting it live onto this.
Troubleshooting computers.
Yeah.
Yep.
If you're having AV problems, you're having an authentic Microsoft experience.
Yeah.
There you go. There you go. Are you on the call? Who's muted? Okay, cool. On to the next one. This is from Philip, and he's writing about an interesting thing here where he did controllers as action filters in ASP.NET Core MVC. So the idea here is he actually wiring two things together. He's using a controller as an action filter. So this seems like a pretty I don't know of a case where I've actually run into where I've needed to do this, but it's interesting that you can do that. So you can use logic from a controller as an action filter elsewhere.
The case where you need this, by the way, John, is if you want to have some common initialization code that runs for all your actions, but needs to have access to the request. Because when you're inside the constructor of the controller, the request property hasn't been set yet.
Ah, okay.
Yeah.
All right. I am doing the tweeting to let people know that we're trying to get in.
Tweet that trivia about MVC.
Right. Okay.
With no context.
No context, people. Okay. Then they'll definitely rush to join. Okay.
Gareth on the chat's asking about the structured logging thing. Gareth, if you think something should be improved there, like file a bug on ASP.NET/home, and we'll discuss it.
Cool. All right, Steve Gordon. So this is using type clients from singleton services. So the idea here is exploring different approaches for injecting a typed client into a singleton service.
Yeah,
so
this is your stuff, Ryan.
What's that?
Ryan works on this stuff.
I haven't read this post though. I'll have to read.
Yeah. Honestly, this one's relatively in depth. He does, as always, have some good code there, and links out to GitHub as well. So, this is cool because he's had a lot of things in the service or in this series where he's kind of gone into this. So this is cool. All right, some fun stuff here. We've looked at Tech and Power benchmarks. Recently they're actually released. Last time we were looking at, they were just about to be released. So this is their blog post talking about them being for real released. So that's exciting. The results are pretty much what we dug into last week on the call. So I'm not going to go into it more, but that's.
But they're amazing.
They're super amazing.
I didn't know those have been released already. Okay, that's sweet. Yeah. Man, .NET Core is looking
really good, right? Yep. So here's an interesting thing that developed just over last night. Ben Adams was tweeting about wanting to see F# on Tech and Power as well. So long Twitter thread, and as a result, there's already a pull request in. So this is using Giraffe, and this is F# in the Tech and Power benchmarks. So very cool. Cool to see the community jumping into this, and if people want to continue to contribute, here's the pull request. So that's neat. Okay, now to the Blazor section of the show. So when I talked to you, Dan, you pointed me to the community section on the Blazor.net site. So this is the top link, I think, of the week. This is huge. So these are places where you are listing these, and I think people can also recommend things because this is.
See that improve this? If you can zoom in on improve this doc in the upper right hand corner there.
Yeah, let me see if this works.
Just click that. If you have a project that you think that we should share with the community around Blazor, just click that. Submit us a PR. We'll take a look at it, and we're happy to add stuff here. I see a bunch of folks on the call actually that have contributed stuff that's on this page, and we're happy to add more. So let us know the good work you're doing with Blazor.
Cool. So a lot of good stuff on here. You picked out some favorites here, and we'll point those out. So this one is Blazor Strap. So these are Bootstrap 4 components for Blazor. One of the things, like I've done some presentations on Blazor lately, and one of the things I always like to point out to people is that it is, people make guesses. I think it's, like Silverlight or whatever it is, and I think it's great to really make sure people understand that this is web technologies. It's browser standard stuff. So all your CSS, JavaScript, HTML library stuff you can continue to use here. So Bootstrap 4, easy to integrate that. So this is very cool. These are components that work with Bootstrap 4 components that work with Blazor.
Yeah. So just for anyone who's not sure how those two things go together, like you can use all the existing third-party stuff, but there's also a package for it. The reason for that is you can just pull in the Blazor CSS, the Bootstrap CSS files and JavaScript and just use it directly if you want to. But this Blazor Strap gives you nice Blazor component wrappers around it, so you get all the IntelliSense and the normal idiomatic Blazor type APIs for working with them. So it's just a convenience, but you can just use Bootstrap natively if you wanted.
Cool. I was looking to see if. I guess the docs he's got separate. Well, I don't know. Let's see if that. There you go. Some pretty docs too. So very nice. Cool. That is fancy. Okay, another. Oh, go ahead.
You got it. You got it. Keep going.
All right. So the next one is Blazorous. I'm going to learn from my lesson on the previous and go straight to his cool site here. So this is Maintainable Css with Blazor. So. Honestly, I just learned about this right before the call. I guess the idea here is we're doing, this is like a fluent interface for creating CSS. Does that sound right?
Looks like it.
Yeah, looks like it, huh? Okay, so cool. So very cool. And then one more here is some polyfills. So this includes polyfills for Blazor for IE 11 support and some other browsers, I guess like Buggy Safari with WebAssembly. So very cool. And I don't, and then also here you pointed out the Xamarin template for launch. So explain this one to me. This is Xamarin and Blazer, and I'm not sure what we're doing here.
So I haven't actually played around with this one personally yet, but from what I understand, this is integrating Blazor into a Xamarin application through effectively a web view. So you can use the Blazor programming model from within a Xamarin application. That's basically what I get from this one. So it's certainly interesting to try out.
So is it an alternative to using a Cordova wrapper, for example?
I believe so. Yeah, so there's a template for launch and interop a Blazor app on mobile. So
wow,
it's pretty neat. It'd be great. The Cordova angle is interesting as well. I don't know if anyone's actually tried Blazor within the Cordova application, but that's been on my my list of things to go try out. If someone beats me to that, feel free to share that. We'd love to have that on the community page as well.
Cool.
Good work.
All right, and the last one here is Blazor extensions. I'm not sure. I don't think I pointed this out, actually. I've had it bookmarked for a while, and I don't think I've actually shared it yet. So these are additional extensions. So I think a lot of these are these kind of component. Well, you've got a Canvas component, but you've also got storage. I think storage is really interesting, right? Because you've got browser-based storage. So being able to take advantage of HTML5 storage on the client is pretty cool. I've seen a few different implementations where people have done that. So these are curated here, though, huh?
Yeah.
Oh, and SignalR too. Whoa.
So SignalR, I don't think he's made any progress on that one yet, because probably because we told him that. Well, hold on, we're working on one ourselves. Javier's actually been working on a Blazor SignalR client, but most of the repos in this org are JavaScript interop based projects where they take a browser API, wrap it in a .NET wrapper so that you can use it from within a Blazor application. That's like the Canvas and storage cases. The logging one, they took Microsoft Extensions logging and wrote a logging provider that works within a Blazor application. And then there's some component stuff in there as well. Like the last one, like Blazor Materials, is exposing like a material style components within a Blazor application. And the idea there is to just keep adding more stuff. It's sort of a place where community members can get together. If you have an interesting extension that you want to share with everyone, it's a nice, convenient place to find and discover those extensions, and also to share them.
Very cool. Okay. That's all I've got for the week, and I think everyone wants to see what you folks have to show. So over to you.
Cool. Okay. Well, we just shipped Blazor 0.4. It's out. Woo! So if you haven't downloaded it yet and installed it, you should go do that. Go update your apps. It should be fairly straightforward update if you have existing Blazor 0.3 applications. There weren't really any big breaking changes per se. It's just updating the packages. And there's a bunch of new stuff in that release that we're gonna Steve's gonna do a bunch of demos. There was I think the biggest features that come to mind are the JavaScript interop. Like we did a bunch of a facelift on the interop model to make it easier to go from .NET to JavaScript, both synchronously and for asynchronous APIs. And then the JavaScript to .NET path was pretty hard before. It was actually a fairly low-level API that you had to use in previous versions of Blazor. Javier made that almost trivial, right, Javier? You can call any you can call synchronous and asynchronous .NET methods from your JavaScript code. So that should be fun to play around with if you've been hoping to write some JavaScript interop libraries, like stuff to contribute to that Blazor extensions repo. It should be a lot easier to do now, and there's still more improvements that we expect to do in that space. Yeah. But it's pretty good right now. So that's one of them. Another big one was the support for fleshing out our event handling types so that you can get access to the actual event data for keyboard, mouse events, progress events, wheel events. You could handle these events before, but the event types didn't really have any convenient properties on them that you could just consume to get the event data. We had a great contribution from the community where someone went through and fleshed all those out for us, and those are now available in this release. And there's a bunch of other stuff, but it's probably easiest just to show it. So I don't want to steal Steve's thunder. Mm-hmm. So Steve, do you want to show us some of Blazor 0.4?
Yeah, I'll do that. Yeah, tell me, can you see my screen right now?
Yes, I can.
You can. Good, right.
Folks in the chat, let us know. Can you see it?
Well, I'm sure they can, but interrupt me if anyone seems to have a problem. All right, then. So like Dan just mentioned, we've shipped Blazor 0.4, and there's a bunch of cool things in there. And I want to demonstrate a couple of them to you. But I'm not going to show all of the new things that are in 0.4 because I want to probably spend the majority of the time showing off some demos of possible future things that we have not shipped yet, stuff that's just brewing in our minds at the moment that we really want to get people's feedback about. Okay, so the two things that I am going to show you that we've already shipped are, firstly, well, actually, I think both of the things. No, one of the things that Dan just mentioned and a different one. So the first thing I'm going to show you is a cool enhancement that we got from, I think it was Robin Sue in the Blazor community, the ability to do binary HTTP requests and responses. And then I'm going to show you the work that Javier did on improving the JavaScript interop. And I'm going to try and tie those together into one cool little demo. Okay, so firstly, this thing about sending and receiving binary content, you might be thinking, what's the point of that then? I can already send and receive JSON data, so why do I need binary stuff? So quick group quiz. What are the potential use cases for sending and receiving binary data?
Sending, I don't know, an image.
Yeah.
You might want to deserialize the data yourself.
Yeah, that's right. You might want. What was that, Ryan?
People are saying images.
Yeah, loads of images.
PDFs.
Yeah. Okay. All right. So there's loads of good reasons for it. Enough of that. I'm just going to show you some stuff now. All right. So what I've got is a Blazor application, which is hosted on ASP.NET, and it's going to make a request to the server. And at the moment, it's just going to use traditional JSON serialization when it talks to the server. So let's just start that up, and I'll show you the code behind there so you can get familiar with that before I change it to use the new feature. Okay, so if I go over onto this purchase page here, you can see this very, very fake sort of checkout screen where I can type in a product name and quantity and so on. And then I can click on this post button, and that's going to make it do a post request to the server, and it will be JSON formatted. And the code behind that is pretty simple. If I go into this purchase page here, you can see that it's a normal Blazor component. It's using some HTML, a series of divs there to display each of these form elements. And each of the inputs uses bind to associate itself with a property on one of my domain objects. And I've got this object, this class called purchase info, and I've set some initial properties on there, although the user can edit it. And there's also a button that you can click it, and it will call this method submit order async, and that will asynchronously do a post request to the server, and it will be JSON serialized, and it will go to this API orders order. Okay, and so let me show you that actually running. So if I open up my browser network tab here, and then I click on this post button, it's going to do a post request to the server. You'll see that the server has responded with a 200 OK. And if I go into that, you will see that we've made the request to this API, this URL that I specified, and the data we sent was JSON formatted, and the response that comes back from the server is just this plain string that says, okay, the server did receive your order, and to prove that, we're just going to repeat some of the stuff that you sent back to us. Okay. Now the server-side code for that is pretty simple. It's easy to receive JSON data in a ASP.NET application. I've got this orders controller with an order action, and it's going to receive from the body of the request a purchase info object. And so that can be formatted in any way that ASP.NET knows how to deserialize, and JSON is built in there by default. And my purchase info contains all of these properties. So it's the same actual class that I'm using on the client. And I've got this shared project here. And if you can see, I've got my purchase info as a class in shared there. So it's the same actual class used on the server and the client. I don't have to keep those things in sync. Okay. Does that make sense? Have I missed out any critical information so far about how that works?
That made sense to me. Yeah, I got that.
Good. You got it.
Yep.
Great. All right. So that's the traditional way of sending JSON data. Okay, but we've got .NET on the client here, and we've got .NET on the server. So do we really want to use JSON, JavaScript object notation, as the communication layer between them? JSON obviously originated in the JavaScript world, and it's a very nice serialization format. It's very human readable and friendly, but it's not very efficient on the wire. It repeats lots of property names all over the place, and it contains loads of symbols like braces and colons and things like that that wouldn't really be needed in a more low-level serialization format. So you might think, since we've got .NET on both client and server, couldn't we use some kind of binary serialization format? And the answer is, of course, yes, you can. And there are lots of different libraries that enable binary serialization. And one of the ones that people really like is a format called protocol buffers, which was originally defined by Google, I think. And there's a really good implementation of protocol buffers for .NET called protobuf.net. And that's what I'm going to use. And in fact, I've already referenced this NuGet package called protobuf.net, which was created by Mark Gravel, who's quite prolific in the .NET community. And using that, I can change how this data is serialized on the client and how it's deserialized on the server. So to use protobuf.net, you go to your .NET class and you annotate it with these extra attributes. So I've added proto contract and proto member and stuff. I'm not really going to explain what that is. You can go to the protobuf documentation if you want to understand what that's all about. But basically, that's the information I need to give in order to serialize this in a nice binary way. So now I've got that, I can write some code on the client to serialize my purchase info object using protocol buffers. And in fact, I've made a little utility method called toBytes that's going to call the methods on protobuf.net to convert my purchase info object into a byte array. Now, how that works internally is not very interesting to us. The point is that we get some bytes that is the serialized version of our purchase info. And once I've got that, I can change the code that I use to call the server. So I'm not posting JSON anymore. I'm just going to do a regular post request. And I'm going to say, I want to send a byte array content, and the content will be the bytes that I got back from protocol buffers, okay? So I'm going to recompile that now, and we'll see what happens on the client when I start to try and make that request to the server. Let's see whether it works. So I'm reloading over in the browser, and then I'm going to have a look in the network tab again, and we'll see what actually happens this time. So when I click on post now, you'll see that we don't get 200 OK anymore. We now got this 415, which is something like media type not recognized, or unsupported media type.
Yeah. Unacceptable.
Yeah, totally unacceptable. How dare you? Okay.
This is the worst demo ever. That's terrible.
So that's the thing that we'll fix in a minute, all right? But did the client do its job properly? Firstly, let's have a look what happened inside the client. If we look at what stuff got sent by the client, you'll see, well, it was sent to the orders endpoint. And if we go into params, it's not JSON now. If it was JSON, we'd be seeing it in JSON format, but it's not. You can see that this is some kind of binary stuff that Firefox doesn't even know how to display, hence all these red dots. It doesn't really know what's going on. It's just some series of bytes. And the response from the server is, I don't know what you're talking about. What are these bytes that you're sending to me? Okay, so can we make the server receive a protocol buffers request and do something useful with it? Well, obviously we can. So let me show you. The very easy way of doing it is to add a reference to a NuGet package called Web API Contrib Core Formatter Protobuf. And if you do that, then you can go to your server-side config and say, add protobuf formatters. And you don't have to make any changes to your controller code. It just ties in with how MVC deals with deserializing incoming requests. So if I reload now, once it's recompiled the server and started the application up, it should behave a little better this time. So let's see. If I hit post again this time, instead of the 415, I get a 200 response from the server now. And if we look in the response there, you'll see the server said, yes, I did receive your order for the cat monocle, and I was able to deserialize it correctly. Just to prove that it's not just fake hardware data, if I change that and make another request, you'll see that the stuff I typed in came through there. So we now are free of the tyranny of JSON. Well, we've got a server that can receive JSON if it wants to. You see, I could still send JSON to orders control and it would still receive it and work correctly. But I can also send protobuf formatted requests to the server for even more efficiency. And that is thanks to the fact that we can now send and receive binary content on the wire. Okay, that's all good.
I think that's a huge cool feature there that you've shown is just that you can use a NuGet package on the client and server. Like, yeah, that's really cool.
Yep, that's right. I had a
NuGet package at all. Was that just the vanilla off of NuGet package?
Yeah, that would be a fake demo, and I don't do that sort of thing. That would be dishonest if I had changed it in some way. I've never done that, honestly. But no, I did not change the package in any way for this demo. It is literally out of the box. Yeah. Okay, so that's one of the two things I want to show you. The next thing I want to show you from point 4 is the JavaScript interrupt improvements that Javier was working on. And one of the cool things with the newer version of the JavaScript interrupt is that it enables us to deal with asynchronous methods that we want to call. And so why would you ever want to call an asynchronous method? Well, because things happen asynchronously, and increasingly over time, browser APIs are starting to return promises rather than just pure results. So in JavaScript world, asynchrony is represented by promises, and in .NET world, asynchrony is represented by tasks. But these are almost equivalent concepts, and it's quite easy to map from one to the other. So that's what we're doing. If you call a JavaScript method that returns a promise, then the .NET code receives that as a task that you can await, and vice versa. If you call .NET from JavaScript and your .NET code returns a task, then the JavaScript code gets a promise and it can await on that as well, making the interop quite easy. So let's give an example of a asynchronous API that we want to call. Let's say that when I place this purchase order, I want to get some payment information from the user. I want their credit card details and shipping address and such so that I can charge them for it. Now, you might not know, because a lot of people don't know, but for at least the last 6 months or so, browsers have had a native API for collecting payment requests from users. So browsers can show some native UI to say to the user, hey, this website wants some money from you. Will you give it to them? And it lets the user select from the payment details that have been stored on the device. So if they're on a mobile phone, it will be whatever payment details they've stored for their app store or whatever, and they would confirm that payment by using a fingerprint or Face ID or whatever that device wants to do for confirming things. Does that make sense? Have you heard of that?
This is our new plan for getting Blazor funded. It's the
yeah, that's right.
Donate here button. Right?
Yeah.
A small proportion of all purchases will be skimmed off by me. No, not really. Please don't decompile the code. All right. So the JavaScript code that I want to call to make this payment request looks like the following. And it's quite a long block of code, but trust me, it's not that difficult. So what I'm doing is I'm saying, okay, using the normal Blazor interop APIs, I'm registering this function with the ID request payment, and I'll be able to call that from .NET code. And it takes a couple of parameters, product name and total price. And then I'm going to use the JavaScript payment request APIs. I'll say, I'm going to create a new payment request, and I can configure that in loads of different ways. I can say which methods it supports, what line items, what tax, what grand total, all kinds of stuff I can use to configure that. But I'm not really getting into that. I'm just displaying these two items, the product that you're trying to purchase and the grand total, okay? And when I've created that payment request, I can then say request.show, and that will return a promise of type promise of payment response. Because it's asynchronous, the user can spend any amount of time that they want to interacting with the UI that comes up there, and when they finish interacting with it, that's when the promise will complete. And so we're returning this result promise back to .NET code. All right. And so I want to receive this, the result of that promise asynchronously inside my purchase Blazor component. So to do that, firstly, I need to import the namespace for browser interop, which is this quite unwieldy long thing there. So the browser interop import. And once I've got that, I can say registered function dot invoke, but not just regular invoke. You'll see now, as of point 4, we've also got invoke async, and that is going to return a task so I can await on it inside my .NET code. And in fact, the actual code that I want to call looks like this. I'm going to say, I'm going to await for the result of this task. I'm going to call request payment. That's the ID I registered it with. I'm going to pass the product name. I'm going to pass this completely fake price into it. And that's going to return a task that I can await. And eventually that will complete with a payment details object. And I'm going to put that onto my purchase info so that it gets sent to the server. And if you're wondering what payment details class looks like, well, I've declared that inside my shared class library here. And it looks like this. It's got loads of stuff on it: card number, security code, expiry month, billing details, all that kind of stuff. And I got this list of property names just by reading the JavaScript documentation for what stuff gets returned from a payment request. And Blazor will deserialize all of that stuff into an instance of payment details. And then I'm using protobuf to send that to the server. And then my server-side code, which is using the same class library, will get the payment details, and I'll have access to that on the server. All right, do you believe me? Does it sound plausible? Let's try it out. All right, so now, in fact, I have to do this in Chrome. The reason I have to do it in Chrome is because I think Firefox is the last browser to implement payment request support. They have confirmed that they're working on it, but they haven't done it yet. But I think all the other major browsers have done it already. Anyway, so I'm going to do it in Chrome, and then I'm going to show you what happens. Let's look at the network tab so we can see the request going when it does. Okay, so I'm going to click on this post button. And so now that's going to call my JavaScript function, and you'll see this native UI appears. Review your payment. Okay, and inside there, I can click and get a list of the stuff that I'm ordering. I can go in and choose from the payment details that I've stored in my browser. And then finally, I can click on this pay button. And because it's Chrome, Chrome chooses to ask for confirmation in the form of this CVC number. Other devices might ask for a fingerprint or something like that. Anyway, I'll type in my CVC number. And when I click on confirm, you'll see that the promise completed. And so immediately, it is able to make this call to the server and pass all the information to the server. And so let's check what was in there. If we look in the, if we look down here at the bottom, you'll see we're sending the same information as before, but we're now also sending all this stuff that came back from the payment request, such as the card number and the shipping address and things like that.
Why is it so hard to read? It's really hard to read your JSON. Oh.
It's not JSON.
People are going to steal that credit card. Please don't use Steve's credit card.
Sorry. I'm very our community is trustworthy. I don't think anyone will abuse this information. Yeah. Anyway, you can see that yeah. Apologies to any people who are actually called Fakey McFitface. Anyway, so the server did get that data, and that's the power of having proper asynchronous interrupt between .NET and JavaScript. Okay, so that's that. Any thoughts or remarks anyone wants to make about that before I move on?
Well, I'll be more impressed when you implement blockchain, but this is a good start.
All right, cool. All right, so that's some stuff that we've implemented in the 0.4 release, but we didn't implement a whole lot of new functionality in 0.4 because one of the biggest things that we were focused on actually was prototyping some potential major new things. Because Blazor is in an experimental phase, we are really interested in trying the widest range of things that we can in order to get the most interesting sense of all the stuff that you could really do with Blazor.
I feel like there should be a drum roll here or something. Like, well, wait.
All right. So we're interested in what other application delivery models might exist for a Blazor application. And one of the obvious ones that quite a lot of people have asked us about already is, what about Electron? What if I want to make a cross-platform desktop application that people can install and use offline and think of it as just a normal installable desktop application, but actually implement it with Blazor? So you get to use all of your web programming skills, but you also have access to all the native APIs in your operating system. And so we went off and we had a go at doing that. And we needed a realistic application to act as a test case for that. We didn't want to just do some silly hello world thing. We wanted something that really looked and felt like a real application. So we decided to use the Azure Storage Explorer. That's a real thing that Microsoft actually ships. That's a desktop application that you can install to see everything that's inside your Azure storage accounts, such as blob stores and things like that, and upload and download stuff and generally work with those accounts. So we took some of the UI code that they implemented for that in CSS, and we built an Electron application with Blazor that looks and feels quite similar. So let me just start that up, and then I'll show you some of the code that's inside there. Why do I have build errors? Let's see if I rebuild. Does that make it any better? Let's see. Any time filling thing that anyone can fill in while I fix my code right now?
Let's see what questions do we have in the chat.
Well, people are continuing to ask what's the kind of like, when do we get it for real? All that.
Oh yeah. We didn't say that. We should say that. So
when we know, you'll know.
Yeah, you will definitely know. It is still an experiment.
You won't miss it.
I'm sorry. It's still an experiment, so don't go using this for production apps just quite yet. Still, honestly, the reaction to Blazor so far has been fantastic. Like, people have been giving us lots of great feedback on it. So things are looking, I would say, looking good in terms of Blazor's future, but there's still nothing committed yet. There's no committed time frame. People are asking, like, when's the 1.0 going to ship? We don't have a committed time frame for a 1.0 at this time. But as soon as we know more about the Blazor roadmap, we will be happy to share that with everyone, and you will know.
The way I tell people that they can register their excitement is by installing Blazor, going to blazor.net, go to get started, and then fill out the survey.
That's exactly right. And we've been looking through those surveys, and the feedback there has been very helpful.
The surveys help us. The install numbers help us. The seeing the kinds of things that the community builds with Blazor and the engagement with libraries and apps helps us. I mean, all these things help us.
Yep. We look at all those things. Everything with people talking at meetups, people doing presentations on Blazor, that's all helpful to make sure everyone knows that this should be a thing. So we're optimistic, but unfortunately nothing official to announce at this point.
Cool.
Excellent. All right then. So it compiled. So I'm going to start this running now. So when this pops up, this is going to be a desktop application running inside an Electron shell. And here it comes. And it looks exactly like the normal Azure Storage Explorer, although we've renamed it to the Storage Blexplorer. That was Ryan's.
This takes me back to the Project K days when everything started with a K, and now we have the...
By the way, for clarification, it's pronounced B-Electron. It's not B-Electron.
Okay, right then. So this has got some of the functionality that's in the real Storage Explorer, such as I can expand this tree and I can look at all the storage accounts, and I can look at my blob containers. I can open things in tabs. I can pin tabs. Let's just open a few tabs and have them all pinned. And then I can see the stuff that's actually inside my storage accounts. And then I can do things like open them. For example, this first thing at the top, you can see that's a bitmap image. And so if I click on the open button, what's that going to do? Well, that's going to download it, and it's going to open it in the operating system's native image editor. So that's not the sort of thing that you can do from a normal browser application, but it's not. It's an Electron application. This one down here, this is a text file. If I right click it, you can see firstly that I've got a native operating system context menu there. And when I click on this open, that's going to open in Notepad because it's a text file. Okay. And that's pretty much most of what we implemented, okay? We tried to make the UI feel pretty good. So you'll notice that things like the state between the tree view on the left and the tabs is synchronized. So as I move between tabs, have I just killed it? What have I done? Oh my goodness, right, I've just done something that killed it.
Both the same space.
Yeah. All right, let's start that back up. It is a prototype. I'm sure there are bugs. Let's start.
Yeah. So we were working on this during 0.4, and it was a proof of concept effort, like an internal investigation. So that's like there was nothing released with the Blexplorer bits as part of 0.4, but we wanted to share it with you guys so that you could see what stuff we've been working on, the progress that we've made, and how Blazor really can apply to a variety of application models, not just for in the browser scenarios.
Yeah. Cool. All right.
So I'm interested to hear, as you built this out too, what did this kind of drive you to say, oh, wow, we really need to implement this feature, or, like.
Actually, what happened is we said we really need to go buy GitHub. And so, this is all based on Microsoft technologies now. And
Right.
Yeah.
Not quite yet. Sorry, not quite yet. I'm ahead of myself. The deal hasn't gone through yet. So
I think to John's question, I think we had hoped to find a couple of those things, and I'm not sure that we really did. I mean, maybe the one thing that came out of it was we'll need to think about what does it mean to write a larger Blazor application. What would be our guidance for how to structure an application? How do you do state management? Mm-hmm. And what would be a default story that we would put in the box? But there weren't. We were able to build this pretty effectively with the things we have. There weren't too many extra things. The big challenge that had to be solved to get this working was mostly related to interop, and just what does the interop story look like in Electron versus in the browser.
Okay. Well, two other quick questions. I don't want to divert you too much, but I'm interested that you mentioned state management. What sort of state management are you using?
We're using a pattern that's essentially like a grown-up version of what we have in the Flight Finder sample. If you go on the ASP.NET samples repo, you'll see a small application called Flight Finder, which has this very simple state container with C# events. And basically, we've used that same pattern but scaled it up here. So I think we've learned a little bit about some of the limitations of that and how we might want to expand that guidance, but it's kind of too detailed to really get into that.
And then the one other thing, component-wise, is this tons of like nested components? Do you have some kind of large components?
Yeah, so let me show you some of the code that's inside this. So I'll go through that a bit quickly. But actually, before I do that, one other thing that we wanted to use this as a little test case for was around performance. So we wanted to make sure that we can make really, really big UIs with like vast number of UI elements and nothing would slow down. So we've got this infinitely deep tree here that you can keep on expanding for as long as you feel like it. And over on the right here, you'll see we've got this grid. It's quite a big grid. It's got a lot of items in it. If I scroll down to the bottom, you'll see that, I've got to actually scroll to the bottom. You'll see we've got 100,000 rows in that grid. So that's a virtualized grid. And there's not really any perceptible delay as we're moving around. So that was a good sort of validation of some of these, of some of the ways that this works internally. But anyway, on to looking at a quick bit of code. So it is a normal Blazor application. I'll talk about how it interacts with Electron in a second. But if I open one of the Blazor components here, here's the app component. And yes, John, as you suggested there, it is Blazor components all the way down. So at the top here, we've got a few Blazor components, reference, vertical toolbar, nav panel, tab panel. If we drill down into the nav panel component there, you'll see that this contains some of the things that you've seen in the UI. It says Explorer here at the top, and you'll see that's why it says Explorer up here in the top left. And then underneath there, we've got the search area, we've got action links, then we've got this nav tree below that. And if we look inside nav tree, you'll see nav tree basically just iterates over all of the root level tree nodes and renders a nav tree node. And if I drill down again into nav tree node, that contains loads of markup that's way too boring to read and explain. But one bit about it that is worth looking at is it's a recursive component. So each nav tree node iterates over its own children and renders more nav tree nodes. And that's how we get this recursive tree of nav tree nodes all the way down. Does that make sense?
Yep.
Excellent. All right, cool. So let me just quickly cover how we're doing the interop here between .NET and Electron. So the obvious way to run a Blazor application under Electron would be literally just to take a normal browser-based Blazor application and just run it in Electron, because Electron is a Chromium frame, so it can run WebAssembly, and we could just run Blazor under WebAssembly inside Electron, and that would work absolutely fine. But we wanted to try a slightly more ambitious approach of not doing that, and in fact not using WebAssembly at all, but rather running .NET natively under the normal .NET Core runtime and having that interop with the Electron shell. So if you look at what type of project this thing is, you will see that it is a console application, which is why when I started the thing up, this console showed up, and from there it launched Electron. So it is a normal .NET Core console application where all your Blazor code is running under regular Core CLR, not under WebAssembly, and it's interacting with Electron shell. Does that sound right?
Yeah. Okay.
Okay. So that's not because there's anything bad about using WebAssembly. It's because there are pros and cons both ways, but there are some really good advantages of running your .NET code natively under Core CLR. For example, it runs much, much faster, and it means you get full Visual Studio debugger support straight away. And it also means that you can use literally any NuGet package without any restriction at all, because, you know, it's just a normal .NET Core console application. And yet you can still do all the stuff that Blazor does, and you can do all the stuff that .NET Core does when it's running as a console application. Okay? Wow.
Yeah. Yeah, this is really cool.
Okay. All right. So we're not making public the actual Blexplorer application, because that contains quite a lot of stuff that's specific to, well, things that you don't want to get into, and we don't necessarily even have permission to redistribute. But we know that some people will want to try this. So what we did is earlier today, I published this Git repo here, a Blazor Electron experiment sample, and you can try that out yourself if you want to. And that contains a Blazor application that runs in Electron using the same architecture that I just showed you. So it's running the .NET code under normal Core CLR, and it's doing the interop to the Electron shell. So if you clone that repo, you'll get this project here. And if I start that up, and it compiles correctly, which it does not. This is pretty frustrating. I have to keep, it's because I've got more than one version of the .NET SDK on my machine, and Visual Studio gets associated with a specific one, and then it does not like it when I'm switching from one to another. Let's try that one more time.
While we're letting you sort that out, Steve, someone's asking about the interop stuff and asking if we will support observer interop in addition to promises interop. I don't know if anybody, I haven't had any thoughts on that. Does anyone have any thoughts about observer interop with Blazor?
It should be able, we should be able to build it with, or like it should be possible to build it with the current interop support.
So you should be able to do it yourself on top of the existing patterns?
Yeah.
Okay, so maybe it's something we can do a sample.
Cool. All right. So now it's building, and I Control F5. You can see that we've got the normal Blazor project template, but now it's inside the Electron shell. It's still got routing support. It all works the same as before. And if you've seen a Blazor application before, you'll be familiar with how that's put together. But there's a couple of differences. One is when we're fetching this data for the weather forecasts, normally in the browser, we do that using an HTTP request. But because this runs as a native desktop application, we don't need to use HTTP. We can use file IO, just normal .NET APIs for interacting with the local machine. So in some ways, that's really cool and simplifies things a lot. And the other thing that's worth pointing out is that you have access to all of the Electron.NET APIs. One of the tools that we use to link Electron and Blazor together is this open source project called Electron.NET, and that provides a lot of APIs on the Electron static object there. So I can go and I can call all these different things on Electron.app in order to change what stuff gets displayed in the dock, or to change the jump list in the operating system, things like that. Also, I've got access to the operating system clipboard, and I can show dialogues, and I can use shell commands, all that kind of stuff. So you've really got access to everything that Electron can do directly from your .NET code in a really convenient way. Okay, so if that's of interest to you, please go and clone that repo on GitHub and try it out and tell us what you're thinking of that sort of thing. But I'll just caution you, we're not supporting any of that at this stage. That's purely a proof of concept type thing for you to experiment with. I wouldn't recommend building a production application on it just yet. Make sense?
So completely unsupported, crazy experiment. But what you're showing here, this is a desktop app, cross-platform building. I can build an app using HTML, CSS, JavaScript, etc., and then run native .NET Core on supported .NET Core operating systems, right?
Yeah, that's right. Yeah.
Oh, okay. Very cool.
Yeah. We have tried it out on a Mac. It did work fine. All right, then. So
awesome, Steve.
All right, so that's a bit of a future idea. Now I want to give you an idea for another future idea that we're not at all sure whether we want to do yet, but you know, it's experimental and we're trying out some cool new ideas and seeing what we can do. Blazor's architecture is quite flexible because it has this separation between the .NET part of your application, which is where most of your logic goes, and then the web-based rendering that we do in order to actually display the UI. And you've already seen how a Blazor app can run on WebAssembly inside a browser. And you've also seen how it can run directly on Core CLR and display a UI inside Electron. And this got us thinking that there's other possible hosting models as well. And so another way that you could do it is you could have your .NET code running not on the browser under WebAssembly, but on the server under normal Core CLR as part of your web server. And then it could use a WebSocket connection to the client to send the UI updates into the browser. So the user would have the same experience in the browser, but the code would not have to be in the browser. The code would be on the server. Okay. So let me try and show you an example of that. And this is going to be another one of these cases where I have to switch to a branch and restart Visual Studio. Does my explanation make sense there, or does that just sound utterly mad?
So you're going to take the connection between the Blazor process, which in this case now is going to run on the server, and you're going to stretch it out across the network so that it will serialize and send the rendering diffs and the user interaction stuff down to the browser and back over a WebSocket connection.
That is absolutely correct. Yeah. So whenever the user takes some action in the browser, we send that information over to the server where the Blazor application is running, and then we send the UI diff back down to the client in order to be rendered.
So
Okay.
for really old people, this would be an update panel except cool.
Yeah, if you want to think of it that way.
It's a lot bigger than that, though. It's not just a region. It's not just a region that behaves dynamically. It's a whole application model.
So it's the entire diffs, like you're saying. It's just it's figuring out what the diffs are, and it's just updating those specific parts.
Yeah, so some people are asking about We and how similar this is to the We project. Is that basically a similar model, but just done like with XAML, the stuff that Frank Kruger did?
Yeah, so that's a good way of thinking about it. Okay, so we originally started with this model where it runs on the server and sends changes to the browser. And then later on, Frank added the ability to run on the client under WebAssembly. And Blazor started from the opposite end, running on the client under WebAssembly. And this is an idea of how we could also add the server execution model. So yeah, so I think I don't know whether we can run under both of those models now, but it did at one stage. So this would be a very similar idea to that. Okay, in a way, you could think of it as a very quick way of switching between thick client and thin client. Do you want the actual UI to be on the client, or do you want it to be on the server? Well, it's the same application, but it can just run in either place because of the flexibility of the architecture. So let me start this.
And sorry, not to interrupt too much, but this also helps with something. People have asked me about, like, how does this work with things like SEO and stuff like that? I mean, this seems like I get kind of those advantages too, maybe in the server rendering.
Yeah, if we rendered the initial UI to HTML on the server, then it would help with that. That's kind of a slightly separate thing.
Okay,
and we will implement pre-rendering in any case, regardless of whether the execution is client or server. But yeah, there are a whole bunch of pros and cons, and I'll explain those in a second. But let me just show you this thing running. So as you can see, I've done it for the Explorer application as well. And when I start clicking on things, you'll see it still works the same as before. I've got all the same functionality. I've got my giant grid and everything like that. It all works the same. But what's different about it now is that all of the .NET code is on the browser. I'm not having to send it down to all the .NET code's on the server. I don't have to send it to the browser. So when I click this reload button, watch how quickly the application starts up. I don't know if you can even see it say loading, but it's a sort of less than 1/10 of a second. It's an incredibly quick thing for starting up now. And if we look at the total size of stuff that we've sent down to the browser, I'll do a hard reload. You'll see the application has been reduced to 383 kilobytes now. And in fact, we could make that a lot smaller still, because if we look at what's inside there, the biggest thing by a long margin is this blazor.js file. And the only reason it's massive is because it's unminified and it contains this giant block of source mapping stuff at the bottom that's probably like more than 150 kilobytes or something. So I'd say that with a bit of optimization, we could easily get this application down to less than 100 kilobytes, probably about 50 kilobytes or something. So it'd be incredibly lightweight and starts up incredibly quickly. And the user does not need to be running the application locally. It's all running on the server, and we're streaming stuff. To see it actually streaming the updates, let's have a look at the list of WebSocket connections. If I reload, you'll see there's a connection called _Blazor. And inside there, if we look at the list of frames that have been sent, every time I click on something in the UI, you'll see it sends this invocation to the server that says what's just happened. And in this case, it's a mouse event that's just occurred, a click, in fact, and we know exactly what's been clicked on. And then the response from the server is these binary frames. And I can't visualize those, but it's a very compact representation of how the UI needs to be updated. That's what Blazor normally does when it's running under WebAssembly in order to tell JavaScript how to update. And so it's doing the same thing now. It's just that it's serializing those updates over the WebSocket connection. Okay, so that's just the flexibility of the architecture that we've got. We can run the application in all these different ways. And if we wanted to summarize some of the pros and cons of the different approaches, if you're running on the client, that's in some ways ultimately the ideal situation, because ultimately that's going to give you the fastest possible UI by the time it's loaded. So every time the user clicks on something, you're always going to get an instant response because the application is running locally. There's going to be zero latency in updating the display. Also, if you're running on the client under WebAssembly, your application can work offline, which is important for progressive web applications or places where the user has got intermittent network connectivity. The other benefit of client-side execution is that you, the developer, are not paying for the application to actually execute. So because all your server is serving is static files, and the client brings their own processing power to execute the application. So it's very, very cheap to host. Whereas there are some big benefits to running the .NET on the server as well, such as the application startup is going to be incredibly fast, and you only need to send a tiny amount of data to the client in order to get it to start up. Because you're running on Core CLR on the server, you've got access to everything that .NET Core can ever do, such as all the VS debugging support and all the NuGet packages. Another thing that's really interesting about the server execution model is that whenever you want to do data access, there's no need to be creating web API endpoints. You can just directly interact with your database or file system or anything you want from your .NET code, because it's not inside the client, it's on the server. So you can do whatever you would normally do in server-side .NET code without having to go through additional API endpoints. So I'm really interested to know what people think about this. We don't intend either one of these to be a replacement for the other. I think that there are probably good use cases for either, but I would be really interested in which people feel is the best fit for their particular application scenarios. And don't tell us you're interested in both. That's not very useful to us. Tell us which specific one you think is the one that you would choose for the specific applications that you would like to build, please.
In chat, right, either client or server.
And what type of application you're building.
Sure, that would be helpful too.
Cool. So that, yeah, that's all I'm going to show.
So people can respond on the chat. If people are watching afterwards, should they just leave a comment on the video here on YouTube?
Yeah, tell us in any way they like. We're not trying to conduct a formal poll here, but the whole point of this experimental phase is for us to try out some of the wildest ideas we've got about how stuff can work, and for the community to be able to tell us what we should actually do.
Wow, so there's a big split. I would say it's maybe 60-40 client to server, but yeah, it's very interesting. I mean, of course, the one thing you said that is not helpful, but I think of like maybe a Blazor, maybe it's Blazor 2.0 or whatever, but it's a thing where you have the flexibility of I've got a server model and then I click here to do whatever, and then or click here to install, the Electron based one, like having that kind of flexibility would be amazing.
Yeah.
You know what I mean? Like basically install local version. Oh, wow. So there was a question, somebody was concerned about latency for the server side, but I think what you were showing there is because there are those tiny binary opcodes that you're not really, it's a tiny amount that you're transmitting back and forth, right?
Yeah, that's right. Yeah, and latency is a huge concern for the server-side model. And so in order to try that out, we had to go at deploying this application to a few different Azure data centers around the world. And we went to them, to see what was going to work well and what wasn't. And what I think most of us agreed on was that if the data center was within like 1,000 miles of you, then the responsiveness was really good. Assuming you had an acceptable network connection, then you couldn't really tell that it wasn't executing locally. Those diffs tend to be under 1 kilobyte. It's usually going to fit within 1 TCP frame. So yeah, it's just limited by speed of light. And it's really hard to make that any faster. We've tried, but there are some fairly fundamental physics that we haven't been able to overcome yet on that. But basically, yeah, if the data center is close enough, then it tends to work really well. I also tried deploying to data centers that are sort of diametrically opposite on the planet, and the lag was noticeable. Yeah, so I was getting about sort of half a second of lag between clicking and seeing things update, which is not a super user experience. So you might want to look at some sort of geographical distribution of your application if you've really got a truly global reach for your app.
Very interesting. Thank you. Who's responded on the chat that the comments are helpful as we look at this particular scenario.
Yeah.
Cool. Well, that's all I'm going to share. But yeah, any other questions?
Yeah, as far as then collecting feedback and all that kind of stuff, there's this general kind of questions, and people can get in touch, on the video or I guess on Twitter or things. But probably, if people have questions, feedback, they can also log issues just on the Blazor repo. Is that a good spot?
Totally fine. Yeah. So we're totally happy to take general support questions or general philosophical questions on that repo. We will mark them closed straight away, but we'll also try and answer them.
Okay. There was one thing that was a little bit interesting. Somebody was asking for view style, like Razor operations, so like V-4 or things like that. And I guess some of that is just is a little bit Razor specific, but are there things that you've looked at as far as kind of change, like Razor specific things for the component model, or for bringing in some logic and looping and things?
Ryan?
So I'll speak up on that. So regarding specifically the for and if, the sort of thought there, or at least the thinking amongst the Razor team there, is we wouldn't do something like that lightly, because it really changes the experience for everybody. We would only do something like that if we're going to tell everyone to use it in every scenario, because it sort of changes how the language is defined. Right now, we're in this weird place with Razor where we're trying to catch the tooling up to what you're able to do with the runtime. So it's kind of big sort of foundational things like that are, as far as language support, are not really on our radar at this point. I think when the tooling, we're actively investing in the tooling, and that's an ongoing effort. And we're hoping that in a year or so, the landscape is different there. But it's kind of not a big consideration for us. As something we would do in like the next couple weeks. If you're in Razor, you can build that sort of thing yourself as a tag helper. If you're in Blazor, we don't currently expose a way to author those kinds of things right now. Might we? I'm not sure. It feels to me more like a language feature. Now, as far as language features in general, some of the things that have come up with respect to Blazor are things like splatting, the ability to splat attributes. So the ability to author a tag that replaces another tag and then say, and I want to copy all of these attributes there as well. So the ability to sort of build up a set of attributes in code and then dump them into a tag programmatically, or the ability to dynamically invoke a component are things that we're thinking about. But that's sort of balanced with the other priorities of the Blazor investigation at this point, which is right now we've been sort of thinking about app models and what does a Blazor application look like? What are all the things that are possible? So that's a long-winded explanation. If you like the idea, tell us why you like the idea. We get a lot of people proposing just alternatives to things. We want to know why you think it's important. What problems does it solve for you that you have those things?
Okay, cool. One other thing, and this is just, thinking of features and apps I'd like to build and stuff. I did notice, like, Steve, you've added some things like when you're building client-focused things, sometimes transitions and indications of what's, active and not active while you're hitting the server are really important. So in the Flight Finder, you have the gray out region, and then also I believe you have some kind of transition sort of animations or things where things can kind of fade in or out or that kind of thing. Have you looked to add anything as far as, I don't know, component-wise, like transition things, or is that where you just basically say, go use, whatever libraries are already available in JavaScript?
Yeah, so at the moment, we don't have anything built in that does anything magic for you. So you're kind of limited to whatever you can do with CSS right now. And so with CSS, you can quite easily do things like hover effects and highlight stuff instantly when it becomes clicked on without having to wait for any further round trips. And then you can just use normal CSS transitions if you want to, but it's a bit manual. My general expectation about where this goes is that we would probably take inspiration from some of the other SPA frameworks, which have got things like animatable repeater components. And the repeater is a sort of low-level thing that you can build other stuff on top of, like grids and other higher-level things like that with animations.
Okay. I mean, I would keep you guys on all day talking. This is basically Blazor Conf for me. I love it. But I know we have to let you go.
Yeah.
But I guess we have to let you go and get back to actually building Blazor. So I mean, there's some great kind of, any other big questions jumping out at people? I guess somebody's asking about data templating. as also something interesting. Is that something?
Yeah, it's part of the plan. It just for a few releases now has always been kicked to the next one because there's been something more important.
Yeah, template basic.
It definitely when we were, I think we sort of anticipated the need for that as part of the Azure Storage Blexplorer experiment, and ended up not addressing it as part of that release. It's something we're definitely thinking about.
Okay. I mentioned as a joke, but people are actually saying on the thing, BlazorCon 2019 or whatever. I think it would be really, as things continue to build up, but I think it'd be amazing.
Sure. Yeah. So for
Awesome.
folks, if we don't get folks questions answered for folks in this time, do come and join us on the Blazor Gitter. Like, there's actually a fairly active community of folks there that are chatting about Blazor pretty much nonstop, 24 hours a day. We try to be on there fairly regularly. So feel free to ask your questions in that form as well, and we'll help you out, and happy to discuss anything Blazor related there.
Right, and I put the link to that Gitter in the chat. So, all right. Well, thank you all of you so much for making the time and for the amazing demos and just the cool stuff you've been working on. This is really exciting.
Thank you for letting us talk about Blazor.
Awesome.
Yeah. Okay. So I guess now is the point where we need to get ready for the dramatic zoom out.
Here we go.
How many engineers does it take? Okay. First the zoom in.
Javier,
Okay, now.
Javier, dramatic zoom out.
Okay.
Okay. Everybody in. And Steve is also kind of there, like in theory. Okay. Ready? And let's go. Dramatic zoom out. It's pretty slow, not so dramatic. It's super suspenseful.